In this video, I'm going to go through the steps needed to do unit conversions. I've said it, or wrote it, however you want to think about it. There is more than one way to do unit conversions. I think this one is very straightforward, so this is the one I teach. If you know of one that works and you like, as long as I can follow it, by all means, use it. You don't have to use my method. Here are the steps I follow when doing a unit conversion. Right? I set my starting quantity equal to itself. And then I start multiplying by these things that I call fancy factors of 1. And the reason I call them fancy factors of 1 is because it's a fraction, but the numerator and the denominator don't automatically look the same. So for example, if I want to convert from centimeters to meters, my fancy factor of 1 would be something that looks like 100 centimeters equals 1 meter. Now, because we know our metric prefixes, we know that those are the same distance, but it doesn't look the same. Okay, to change the units in the numerator of my starting quantity, I need to make sure the units in the denominator of my factor will cancel the units in the numerator. If I want to change the units of the denominator, then I put the units in the numerator of my fancy factor of 1 to cancel the units of the denominator of my starting quantity. And I need to keep doing this until I get what I desire. And then I want to think about it for a minute. Use my common sense to check my work. Does my answer make sense? So let's do a step-by-step example. I've put this onto 2 slides, and the reason is just because there wasn't enough room on one. Right? So I want to change 3 miles per hour to meters per second. So step 1, set my starting quantity equal to itself. Right? Step 2a, now I got to redo what I did just above because I want you guys to see it step by step, if you will. I need to go from miles to meters. Okay, well, I know that 1 mile is 1.069 kilometers. You're welcome to use just 1.6. Now, how do I know that? Well, and answer is I've been doing this a while. I have some experience here, right? You may not know that number. However, if you look at the, I believe, back cover of your book, there are basic conversion factors there. And if it's not there, by all means, talk to Dr. Google to figure out what the conversion factor you need is. Okay, so now I'm in kilometers. Kilometers is one of the metric prefixes that I require you to memorize. And hopefully you remember that 1 kilometer is 1,000 meters. Right? And this should not be step 3, this should be step 4. This should be steps 2a and 3 because I've kept going until I got where I wanted to. Now if I take 3 and multiply by 1.069 and multiply by 1,000, I should get 4,827 meters per hour. So let's just check that. 3 times 1.609 times 1,000 is 4,827. Okay, now step 4, use my common sense. Does this make sense? What is a bigger unit, the mile or the meter? Hopefully you're all thinking that the mile is a longer distance. Therefore, it takes more meters to make up that distance, so I end up with a bigger number here than I started with. So yes, this looks like it makes sense. But we're not done yet. We've converted our numerator, now we need to convert the denominator. So let's go to the next slide. Okay. So I'm going to start with the result of the last slide. So, no, not miles. Let's try this as meter per hour equals 4827 meters per hour. Now let's see if I can write it correctly the second time around. And now I need to change the units of my denominator. Since hours is in the denominator here, I need it in the numerator here. I want to get to seconds. Now, maybe you happen to know how many seconds are in an hour. I'm hoping you at least know how many minutes are an hour. So I'm going to take a substep and know that there are 60 minutes in 1 hour. And then I can do another substep where I know 1 minute is 60 seconds. Right? And notice hours cancels, minutes canceled. My units that I'm remaining with are meters per second. Okay, so if I take 4827 and divide by 60 and divide by 60 again, I get 1.34 meters per second. Now, this should again be step 4. Use my common sense. Does this make sense to me? Which is the larger unit, the hour or the second? Hopefully you're all thinking hours, right? Which, if you think about the last slide, would lead you down the line of, wait, since hour is the larger unit, therefore I need more seconds to make up that unit, therefore I should end up with a bigger number over here, but I have a smaller number. Okay, agreed, but there's a trick here. And the trick is the fact that you are in the denominator. And remember, when you divide by a larger number, you overall get a smaller number. Okay, so let me illustrate really quick. Which is bigger, 1/2 or 1/3? Hopefully you're all thinking 1/2. 3 is the bigger number. When I divided by 3, 1/3, I got the smaller number. Right? Okay. One more example. Remember this slide from the scientific notation where I took a number in standard notation, wrote it in scientific notation, and then converted it over into metric prefixes. I want to take and do one of these out so that you can see very carefully how I got from here to there. Okay. So how do I express 1.496 times 10 to the 11 meters in gigameters? Okay, so I begin exactly as I did before. So 1.496 times 10 to the 11th meters equals 1.496 times 10 to the 11th meters. And now I have a conversion factor. I know that there are 10 to the 9th meters in 1 gigameter. I can get that off of the table that I gave you in the metric prefix video, or you can get it from the cover of your book, or you could ask Dr. Google. That conversion factor is out there. Okay. Now, you might be thinking, oh, scientific notation. I have two numbers. All I have to do is subtract exponents, and you know the answer, which would be 1.496 times 10 to the 2nd gigameter. Okay, 11 minus 9 is 2. If you don't remember that, by all means, feel free to plug it into your calculator. Now, the last thing I want to do is take this back out of scientific notation. 1.496 times 10 to the 2nd gigameters. This exponent, because it is positive, tells me that the decimal place has been moved 2 spaces to the left. So, in order to get it out, I need to move the decimal place back to the right 2 spaces, so that's 149.6. This is gone now, gigameters, which is the value in the table.